You've seen the split brain clip. One hand grabs something the other hand never chose, like two separate minds sharing one skull. That's the story the internet loves. Cut one cable, wake up a second person next to you. But Roger Sperry and Michael Gazzaniga's original studies never said that. And a 2017 study in the journal Brain reopened the question and found the split lives somewhere else entirely. Evidence says otherwise. Let's make it evident. Here is the mechanism the story skips. The corpus callosum is a bundle of hundreds of millions of nerve fibers connecting your brain's left and right hemispheres. It is the main highway carrying information back and forth between the two sides, so the two halves function as one. Surgeons cut that highway on purpose only as a last resort, to treat epilepsy so severe that medication could not control it. William Van Wagenen performed the first attempts in 1940. They did not catch on. 2 decades later, in 1962, Joseph Bogan and Philip Vogel tried again at White Memorial Hospital in Los Angeles, performing a complete corpus callosotomy on a patient whose seizures medication could no longer touch. The surgery worked. Seizures dropped sharply, and the patient went on living an outwardly ordinary life. That success is what let Roger Sperry, then at Caltech, start testing what a brain does once its two halves can no longer talk to each other directly. Sperry's team, working with Gazzaniga, then a graduate student, ran a simple setup. A patient stares at a fixed point on a screen. An image flashes for a fraction of a second to the left of that point or to the right of it. Because of how the visual system is wired, anything flashed to the left goes only to the right hemisphere, and anything flashed to the right goes only to the left hemisphere. In an intact brain, the corpus callosum shares that information across in milliseconds. In a split brain, it does not arrive at all. In one classic demonstration, a chicken claw is flashed to the patient's left hemisphere and a snow-covered house to the right hemisphere at the same instant. Asked to point at a related picture from a row of options, the patient's right hand, driven by the language-dominant left hemisphere, points to a chicken. In the same motion, the left hand, driven by the right hemisphere, points to a shovel. Both choices are correct, each one matched to what that half of the brain actually saw. What is strange is what happens next. Gazzaniga asks the patient to explain the shovel out loud. The talking half of the brain never saw the snow. It only saw the chicken. So it invents a reason on the spot. I need the shovel to clean out the chicken shed. That single moment, published by Gazzaniga and Ledoux in 1978, became one of the most cited demonstrations in neuroscience. The formal record behind it runs from the 1962 paper by Gazzaniga, Bogan, and Sperry through Sperry's 1968 paper on what he called hemisphere deconnection. Together, they documented dozens of variations. A left hand identifying an object entirely by touch, while the speaking half of the brain could not name it. One hand drawing a shape the other hand denied having seen. Tested this way, each hemisphere behaved like it held its own separate stream of information. That specific finding has held up for over 60 years. It is easy to see how two minds in one head became the takeaway. If one half can see something the other half cannot, and each half can act on what it alone knows, it sounds like two separate observers, each unaware of the other, cohabiting a single skull. Sperry himself sometimes wrote about a possible doubling of conscious awareness, and popular science ran with it. A second passenger inside your skull. One who never speaks, but quietly steers your left hand. Sperry's work eventually won him half of the 1981 Nobel Prize in Physiology or Medicine, which only cemented the story's authority. It made for a great narrative, and it is not entirely invented. It comes from real data, from real, named patients who volunteered years of their lives to testing. But the leap from each hemisphere processes some information independently to there are two separate conscious beings in this skull is bigger than the original experiments were built to support. For decades, few researchers had the patient access to test that leap directly. In 2017, a team led by Jair Pinto at the University of Amsterdam, working with Paul Corballis, Edward de Haan, and colleagues, published a study in the journal Brain that reopened the split brain question with 2 patients who had undergone a full callosotomy. They ran the classic visual field tests again. Some results matched 60 years of prior work exactly. Patients still could not directly compare 2 images shown to opposite visual fields, confirming that raw visual information really does stay separated between the hemispheres. But on a different measure, whether the patient could correctly detect and respond to a stimulus at all, regardless of which hand or which visual field was used, the textbook rule broke down. One of the 2 patients, identified in the paper only by the initials DDC, could respond accurately to a stimulus shown to either visual field using either hand or speaking out loud, something the classic model said should be impossible. Pinto's team concluded that consciousness itself was not divided. What was divided was access. Which hemisphere could act on a piece of information, not whether the person as a whole was aware something had happened at all. Their paper's own title said it directly: Divided Perception, Undivided Consciousness. Michael Gazzaniga, together with Lucas Volz, published a response in the same journal months later, arguing the results could instead be explained by cross-cueing, subtle signals like eye movement or facial tension that let one hemisphere tip off the other without the corpus callosum at all. Pinto's group answered that reply in turn, arguing Volz and Gazzaniga had not presented substantive evidence for cross-cueing. As of this recording, that exchange has not been resolved. What changed in 2017 was not that split-brain patients turned out to have one mind after all along, settled and done. What changed is that the confident textbook line, one stimulus, one hemisphere, one report, no longer holds without exceptions. And the argument over what that means for consciousness is active, ongoing research, not settled history. There is a second piece of this story that rarely makes the highlight reel: the interpreter. Gazzaniga noticed that the left hemisphere, when it does not have all the facts, does not stay quiet about it. It fills the gap immediately, with total confidence, and no memory of doing so. In the chicken and shovel demonstration, the talking hemisphere was not lying, and it was not aware that it was guessing. It genuinely experienced its shovel explanation as the reason. Gazzaniga argued this was not a split-brain quirk. It is closer to a general habit of the brain, constructing a coherent story out of whatever fragments of information happen to be available, and presenting that story as certainty rather than as a guess. You do this too, every day, outside any hospital. You feel a mood shift and then reach for whatever explanation is closest at hand. A bad night's sleep, a comment from a coworker, and you experience that explanation as fact, even when the real cause was something you never consciously registered, like a change in the room's light or a missed meal. The split-brain patients simply made the mechanism visible, because researchers could control exactly what information each half of their brain had access to. Most of us never get that controlled setup. We only get the finished story our brain hands us, already feeling true. What this does not prove: the foundational split-brain studies were built on a small number of patients. Sperry and Gazzaniga's original testing focused on roughly a dozen patients from that same surgical series, and complete callosotomy itself has always been rare, reserved for the most severe epilepsy cases. Pinto's 2017 challenge rests on 2 patients, tested by one research team. Either body of work is large enough to settle how every disconnected brain behaves, and results have varied between patients depending on how much colossal tissue was actually cut and how long ago the surgery happened. The lab conditions, a fixed gaze, a flashed image, a forced choice pointing task, are nothing like ordinary life, where both eyes move freely and both hemispheres pick up overlapping cues constantly. And the central disagreement? Cross-cueing versus genuinely unified consciousness is not resolved. Treat any single confident claim about what a split brain proves including this video's own account of the 2017 findings, as evidence in progress, not a closed case. So the popular story was half right. A cut corpus callosum really does split what information reaches each side of your brain. What it does not reliably split, according to the best current evidence, is the felt experience of being one person. The more interesting question might be this. If your own brain is quietly filling gaps and handing you a confident story right now, with an intact corpus callosum and no surgery involved, how would you ever know? Tell us in the comments where you have caught your own brain doing that. Toplam uzunluk mil kapisiz des kelime. TTS'de 150 muzodu 60 kelime ber dekaları hızda 9 deka 25 sesnit 9 deka 45 sesnit arası.